Hey, what's up, guys? I've been working on this 3D printed RC tank for a while, and I just figured I would make a video on it because I posted about it on Reddit and had a bunch of people asking questions and asking for the STLs. So it's still a work in progress, but it's getting there. I have two XCC8 ESCs in here, and then I have two electric skateboard motors under here, which you can't see right now. I'm running it off of 3S right now, and I think it goes around 20 to 30 miles an hour. I'm not positive yet. I can go up to 6S with these ESCs, so I'm hoping to get close to 50 out of it once it's complete. So this is like the main frame right here. I'm using a carbon fiber axle because I had it on hand from building an RC airplane. And then I have this piece here that slots onto the front, and that holds on this lid. So this lid can slide into place like this, and then when this screws on, it there's like a little lip here, and it locks this down into place, so you don't have to worry about the lid popping off or like these tiny pieces of plastic breaking. And then back here, it's both glued on, and there's two screws with heat inserts. Because of the glue, I'm not going to take it apart to show you the motors, because, I mean, they're just kind of chilling in there. But then the other pieces that are not on here are obviously the treads, and then these are sliders that go here, and there's also one here, and that's just like a nice flat surface to keep the treads from bowing in when it's driving. I put those on mostly for durability reasons, because it was kind of like slamming onto the ground and putting a lot of extra tension, and the treads broke far less after installing these. Anyway, I'm just going to kind of go through the different generations of treads for a second, because that's the main thing that I'm still working on. Like, this body is definitely a lot better than it was, but mostly I've just been working on the treads and changing the body to adapt to those. So this one is PETG. I stole this from a guy on Thingiverse who designed an RC snowmobile, and I just told a tread design to kind of like give myself a starting point, because I'm not very good at 3D design. That whole tank body was designed on Tinkercad, which is not a very powerful CAD platform, but that's all I know how to use at the moment. So this one never actually made it onto the final design, and I didn't have enough PETG to print more of these. So this is the next version. This one is PLA, just because that's what I had on hand. The difference mostly is I changed the width of the gaps in here to make it so there was less wiggle room. This one doesn't really have much wiggle room, because this piece has already been edited to have bigger pieces, but also because PETG on that machine just didn't print with very tight tolerances. My new machine is much more tight, so there was big gaps in between the pads, I guess, the interfacing pieces. So it was snapping the filament that I was using for track pins, because this was just like I was doing what I could with what I had on hand. So that moved on to this version right here. This is just a ton of those PLA with tighter gaps, so there's pretty much no gap. In fact, there was a decent amount of friction there until it loosened up just by getting run. And this worked pretty good. They did fall off fairly often, and also because it was just PLA pins melted in there. They snapped fairly often just from the pins breaking, but I didn't really have many problems with the treads themselves snapping. And then here's what the hub for that looks like. This is why it kept falling off. Like, those teeth are not very large, so you get a little bit of slack and it just kind of goes off. And you can't put it too tight because PLA wears down quickly, so it would just keep making itself longer. But yeah, this interface is pretty good. I did kind of mess up on this hub, because this was actually designed quite a while ago. This whole project I've been kind of doing a little bit of work on for probably over a year now. I just kind of got serious into it a couple weeks ago. But yeah, these teeth were not long enough for like the speed I was going for, because it's just so much force on everything. You need more attachment. So then I moved on to this design here. This was my own custom design, obviously heavily inspired by those ones. But this one had a problem where these pieces here kept snapping, because like there's 3 here and 2 here, so it was pretty much always this side that snapped, just because there's less room to take the force. One thing I had done is this. I didn't want to like bulge it up like these pieces, so I just didn't, and that definitely affected the durability, especially since these holes are larger, because I started using these steel pins because I needed more durability. So these ones kept snapping. So for the next version, I upped the diameter of these to kind of like be more similar to those versions, because it needed more durability in that segment, and it definitely started breaking a lot less. So I was using these metal pins. So the only problem was, because I was using metal pins, there was no like shear line like there was before, where if something got hit really hard, it would just break the PLA pin. So I was constantly dealing with these treads just snapping, which means that every time something broke, I had to reprint more treads, which was kind of a pain in the butt. I did also have this one. This one never made it past this generation, but this had heat inserts put into here, and the plan was just kind of like, these will interface here, and then this will screw in from the side and to make it removable, but that didn't work. So there's just, treads are not super easy to take apart. So the reasons these ones didn't work is because, well, one, I don't know how well it would have worked, simply just because these threads might have worn down on here a lot faster. I was kind of expecting that to happen. I was thinking I would probably need another version to get this going. But another problem was, because of the way this was set up, this was kind of pulling at things from an angle, so you're missing 1/3 of the strength because you're not even interfacing with the centerpiece. And then it was kind of pulling at an angle so it could come out a little bit at a time and just rip a little bit at a time. So that was how this ended up snapping. This isn't the same piece, it was snapping on this side with the actual tread piece. I threw that one away. But I moved on from that, and I went on to this like full tread. This is just this design, the exact same thing. I have a lot of spares because they kept snapping, and this was like the dirt tread design. And these ones were kind of like a big leap in design, because I had to design the frame to handle the fact that these treads actually overlapped with the body of the tank a bit. And this was kind of like just the test to get into that for the later snow versions. But this one also had a correctly designed hub, more importantly, but also the teeth were long enough to actually handle like not falling off constantly. I also sloped them a lot just to make sure that there was plenty of room for them to like actually get in there, because one problem I had with the smaller treads is if they got like a little out of alignment, they would kind of like, the teeth would catch and it wouldn't spin very well, because it was meant for a much smaller hub with less room for error. But yeah, this was a good design. It definitely was decently strong, especially once I added, again, these sliders for the center. This made a huge durability difference, just because when it was slamming down, it wasn't just putting a ton of tension here, because it had something to push up against. So from here, I was kind of just trying to figure out how to make this more durable, and try to get rid of like the bounce that was happening a lot of the time, and also try to stop it from rubbing on the tank body, because the motors are like, they're so large, and the brackets that they came with are so large that I had to like make the front of it very large, and it was really hard to get the hub of, well, especially this size, to go around that body. So this hub is bigger because this was the first generation that actually dealt with overlapping with the body. So this hub is it's a noticeable size difference. It's not super extreme though. It's a couple millimeters. The problem is, like, if you keep raising the hub size, then you're going to have less and less torque. And one of the big problems with this current design is just startup torque, because I'm using a sensorless brushless motor. So it just kind of like jitters on startup for a bit, especially in the snow. So that's like, it's always a consideration. A couple more design changes I made for this, though, is I lowered the surface area of this front plastic bit, because this was kind of like welding itself to the body, and I also made it so the bearing doesn't go all the way in, so it kind of sticks out enough that you can just have the bearing touching the body, so you're not having plastic, like friction melt to more plastic. And then from here, I went on to the next design, which was designed like this because I wanted to kind of like give it suspension, basically. This is for the motor side, so this one is just the free spinning side, that's why they look different. But this one, the purpose of this shape is that it can like actually compress with no issue, because if it was just like a straight bar, it would have to buckle, and this one I basically just buckled it in advance. So this is 95A TPU. I never actually ended up trying this one because I wasn't quite happy with how it turned out. It just, I'm just afraid that this one would compress mid-run. So my next version was actually this one, and this one is still in the prototype phase, but as you can see, it kind of slots together, so it has TPU springs, but it has a solid outer wheel, which it will definitely make it a lot harder to compress, and because the outer shell itself can't compress, it can't do things like this if it hits a bump. But I thought this might lower the amount that it moves while also giving it some movement. I still have yet to try either of these, just because at this point in time the snow hit and I didn't really have to worry about that. So that is the consideration for later generations, just to see how well it works on dirt, because most of the time the treads break on dirt. And then moving on to the snow treads, I started with this version. So here's it in comparison to this. This one was kind of in the middle stage of development, so this one actually was printed out before I expanded those hubs, so this one is not very strong at all. And it also, I decided, wasn't wide enough because I really wanted it to overlap a lot of the body. And if you look at the tank here, it definitely overlapped, but if you have that here and another on the other side, you still have several inches of just drag on the snow. And that was going to be my biggest problem, I figured, was like just constant drag, and you needed a lot of traction. So I moved on from this design, and I printed this design, which, as you can see, covers a lot more of it versus this one. And this one also has holes so you can insert metal spikes to give it traction on ice. And this was also printed out before I made these sturdier. This was all kind of in preparation for snow. So these all interface together, but I never ended up actually running this. This was just me pulling on it as hard as I could to see how sturdy it was. I use higher infill levels on the ones that actually go on the tank. And then moving on from that, this is the design that I've been running for quite a while. So this one is very similar to this, but I expanded the hub to match this one. And also, these don't interface because I actually made these two outer ones a little bit smaller by 1 millimeter, and then I made these each 1 millimeter wider because these were the ones that were snapping far more often because there's only 2 of them versus these 3. So I gave these ones more surface area by a decent amount. So these ones actually can't interface. This can't interface with either of these. This is quite a bit sturdier. I very rarely have these ones snap. Normally the battery dies or like the lid starts to come off or something before those actually snap. The only thing that really snaps on this is this top pad is constantly snapping off. So I've been trying to work on that. This is all still PLA. I was trying to get as durable as I could with just PLA so that when I moved on to stronger materials, it was quite durable. But obviously, with FDM 3D printing, the layer lines are the weakness, so it's snapping along the Z-axis, and there's not a whole lot that you can do to change the orientation on this because you really need it to be sturdy in this direction because of the holes here, this needs to be sturdy. So the top pad will come off, but normally the track itself doesn't actually snap. So you can keep running it when those come off. The next version, I actually have only printed out of TPU. But this is TPU. It's a lot more flexible than PLA. Like, this doesn't flex pretty much at all. So this one, the idea is that this will kind of absorb some impact. I also made this smaller. So the pad isn't quite as tall, so there should be less forces on it. I figured it would still have enough traction just because of how wide it is. And then I beefed up this a little bit as well. And I made this thicker, and I added a little bit of like this angled bit on the sides and also one here. I made that one a lot larger compared to this version, just to try to beef it up. I have yet to test these. This is going out to be tested today probably. This one is also TPU, but this is 72D, which is a lot harder than this one. So it's a lot less flexible, but it still flexes. So this was what I was originally planning on using, but I have already run some of these and they still break fairly often. So here is the treads after deciding to just run the tank at full speed until one of the treads actually broke. So these are all the PLA ones. As you can see, the ends are snapping off constantly. All of the pads are falling off. But it took a very long time for one of the ends to actually snap. In fact, it wasn't even this one, it was the other one. So the main core is very durable and it can take a beating, but the rest of it is kind of weak. So because those parts kept snapping, that's why I beefed up the things that I did, making this pad thicker, increasing the infill, because obviously that is probably not good. These are wider. That's just like the actual pad thickness went from 2 millimeters to 3 millimeters, because I also don't want to make them too heavy, because that would reduce speed and it would also just not spin as well. It would have a lot more force pulling on things just from its movement. So I'm trying to not make them too heavy while also making them durable. These ones are also the TPU. This is the earlier generation printed out of this TPU, and as you can see, they also snapped pretty readily. Even when it can flex to absorb impact, it still broke. So my thought is it's because the pad came off the top, which made this far more prone to bending, so it was able to just kind of snap off because it had far less support. So that's what I think happened. These are hopefully going to be durable enough to not have this happen nearly as often. And yeah, this is kind of where I'm at with the generations of treads. I have 2 sets of these that I ran at the same time, and that's like all broken. Obviously, PLA was not a good choice for this. This is just what I had on hand while I was waiting for the TPU to ship. And the plan now is just to keep beefing this up using TPU or some other form of filament. I'm going to try experimenting with other things, but the problem is most filaments get really brittle in the snow, especially like PLA is already pretty brittle, so this isn't really a surprise. But a lot of these filaments as well, like TPU that bends really well, can get brittle in the cold. The best one I've seen apparently is polycarbonate is the best filament to not get brittle in the cold and to be durable and impact resistant. But I can't print polycarbonate on my printers. Apparently it's really difficult to print with, and I don't even have an enclosure, much less a nice enclosure. So I'm just going to try to make it work with either TPU. I might get some more PETG and try to print it out of this, because this stuff is supposed to be more impact resistant. But again, PETG gets brittle in the cold. So I guess I'm going to now kind of take whatever flexible treads I have and replace as many of the broken ones that I can, and then bring this out for a test. So here I have just the bin of flexible treads that I have printed out right now. Some of these are the old generation that has the taller and thinner fins. Some of these are the new generation. Some of them didn't print so great. This one, the one next to it came off the build plate, so it has an ungodly amount of stringing on it. See if I can find one of the old generation in here. These ones were also the earlier generation, so this was when I was still trying to like get the filament tuned, and I wasn't sure if I was going to be able to use retraction or not, because using retraction on TPU is kind of difficult. So this was before I used retraction, and that's why the stringing is so horrible. But it doesn't really matter because this is probably going to break anyway, seeing as it's the older, weaker ones. So I'm just going to try to replace as many of these as I can. I don't have enough to replace every single one. I'm going to prioritize, obviously, the ones with the snapped ends, but I'm not sure how far I'm going to get with that. So to replace these, I melted all of the pins in. So what you need to do is you need to drill out the ends where I melted it on both sides normally, and that kind of pushes the pin out, and then from there that just snaps off. You recycle it and then move on from there. And I'm just going to do that for every single snapped one, and then just replace that with the flexible, and then see how many I have left over to just replace the ones with the missing pads. Alright, so I finished attaching all of the tread pieces. I kind of tried to spread out the bald spots a little, so like bald spot here, and then all the way over here is the other big one. There's kind of another one right here. I should have spread that out a little better. But hopefully that will make the treads not just randomly lose traction in one spot while having good traction in other spots. So to put everything on, these are the design that was meant to like have shocks basically. And I'm just using this design because it's the biggest size hub, which is what the frame is designed for. But this is just all PLA. So to put this on, you take out this axle, which allows you to remove the hubs. There's this piece here, which allows you to, you can just reprint this tiny piece to adjust how far or how long the wheelbase is. And then there's another one inside of here. That gray piece, it's kind of hard to see through the wires. So that way you can adjust the wheelbase without reprinting the entire frame. So yeah, you take out that axle, and then that allows this, which is normally here, to slide all the way over to here. And then you just take this, and it's kind of hard to finagle into place, but you lay this over. You try to get it lined up on the back one first, normally. I think I already messed that up. And it's a pretty tight fit, just because it overlaps the frame, so even with this all the way over here, this can't pull back quite as far as you would like it to. And then you pull this forward, and you slip the axle in. Sorry if the camera angle's crap, I can't really tell. And then I'm going to push the axle in so it's ready to go to the next one. And then I kind of have to let this overhang the table so the camera might make it even worse this time. And then you do have to make sure that you put the flaps in the same side. I've done that wrong before, and I've just had to go back and fix it before I could take it out. It's kind of annoying. Probably doesn't make a large difference, but still want them to be as symmetrical as possible. So yeah, you push that on. You line this side up, you pull it, and then you just get the axle going. And that is the mostly completed tank. So it kind of rises up and down at the moment. I have to put these pieces on. Oh, it's stuck. Okay. So these aren't actually symmetrical because this is a weird design, so you have to make sure, see that hull doesn't quite line up, which means this goes on the other side. And that one lines up perfectly. So this screw is also the second screw that holds this spacer on. And you just throw the screws into here, and then you are set. That is the support for the center. It keeps this from sagging too much. The only problem is this is for the old the old hub design, so it is a little on the small side for this. But I just haven't gotten around to printing new ones because I'm still refining the rest of the design, and I'll probably have to print them again. So for now, these work perfectly fine. They remove most of the sag in the tread. I am just using slightly undersized holes in the plastic that are really long to hold this in, so it's not going into anything special. It's just threaded plastic. These don't really need to be held on there too tight, though. For the things that I'm really concerned about, I am using heat inserts, such as the screws that go into this hub to hold it to the motor shaft. Those are using heat inserts. This lid is using heat inserts to stay on. And yeah, this is pretty much the final thing. The only thing missing from here is just the lid, which slides on separately, and then the piece that snaps in front of the lid. So I'm gonna wait until the battery's done charging, and then I'll throw that stuff on and bring it out. So here we go. The whole thing's fully assembled. The next thing you have to do is just slot this on so that the lip is in the front, because that hooks into this to keep it from coming up. Because the plastic that holds this on isn't very sturdy. Like, that will come up pretty easily, and it's just kind of like glued in place. So that thing in the front screws into place, and that's what really holds everything together. So you slide that on, and before you put it in all the way, you just slot the battery under all these wires here. There's no cable management in this thing, kind of a problem. You plug that in. I just like to make sure both of them are connected. I'm just using an RC Airplane controller. Yep, and they both look good. So now I just slot this in here, make sure no wires are in the way. And this, it's pretty watertight. Like, it's obviously not waterproof. If you dunk this in water, it's gonna get soaked. But pretty much every time I run it, it's bone dry in there. I've yet to come back to any actual water in there. Even running it in wet snow or running it in powder, it seems to be fine. Which is kind of the intention of making this whole slotted design. There's not a lot of cracks for water to get into. So you just screw that front on, and that locks everything together. It rounds the front nicely. The back is also pretty rounded. I did have problems with this lid coming off fairly often, which is why I put it so the seam is in the center, because before the seam was here and it kept like kind of catching on the snow and ripping off. So this has been a lot more stable. I haven't had any problems. And then it's kind of hard to run in your hand, but here it is. It's pretty quick, pretty powerful. So I'm gonna bring it outside and try it. So we're outside. The snow is definitely pretty like crusty. It's been melting and then freezing a bit. So it's not going to really sink into the snow as much. I don't know how that will affect things. It's probably going to make it bounce around a lot. Its full speed traction is okay once it starts going. Once the treads get full of snow, it kind of like jitters. We're just going to drive around a bit. Kind of driving it slow because I don't want to break anything yet. Being home on the road speed. It looks like both treads broke. It's actually been a while since that's happened. Normally, the treads don't actually like snap. So, quite know what's happening. Alright, so the lid is still on, which before I have had problems where the lid like pops off and gets into the treads, and that's why it breaks. These, wow, that is a lot of, yeah, so that snapped here. Some of the paddles are breaking. This one also snapped. That, that's up there. This one also snapped. Okay, that is a lot of broken treads. But if you look, like, this does not bend anymore. It's completely solid. Kind of hard to show with one hand, but like, it's brittle now, even though this is supposed to be bendy. Let's see if I can find. Oh, this, yeah, this is the 95A, and it feels like PLA. It just doesn't absorb the impact when this is cold. I think this design would definitely look better on solid ground again, but I'm not going to get that for a couple months. So we're back inside. This is, like, I just brought it inside, so it's still covered in snow and everything. I just wanted to show you that it should be dry inside. Yeah, you just unscrew that, pop that off. You get like a little snow in the start of that crack, but nothing really gets through. It didn't really ride around out there that long, and it was super crusty, so it's not surprising that there's no snow in here with that quality of snow. But yeah, I have driven it in more powdery snow, which is more prone to get inside of things, and also more wet snow, which is just like really liquidy, and I haven't really gotten anything inside of it. So yeah, it's pretty much bone dry in here. Battery's all set. I do not I'm using a RC Airplane receiver, so I have it mounted in the middle, so even if some water gets in there, it should be fine. The motors are splash proof. These are splash proof. They should be good, even if it gets a little wet in there. The real problem we're having is the treads, though. So here's tread number 1. This snapped right here, completely torn apart. Yeah, it just, the problem is it's so brittle in the cold. This is like, let's see if I can find print a new one to represent. So this is how bendy it is not cold. That's the old design, so it is extra weak. And like, I can't bend this. It just gets solid because it's frozen. Like that's the difference. It just doesn't absorb impact. Even these ones, like without looking at them, I can't tell the difference between the PLA ones and the TPU 95A. Like this is really soft TPU, and you can't really tell. It's already kind of thawed a little bit, and it still just doesn't bend like it should. The PLA ones bend just about as easily. So yeah, that snapped there. That's the first time I've actually had a real problem with the snow treads breaking in that spot. Normally the snow treads don't deal with that. Normally it's just the ground treads that were snapping like that because they were bouncing around a lot. So that's new. I think it might be because the snow was so solid. And then here, this one actually snapped in 2 places, which is kind of impressive, honestly. I'm not sure how that happened. But yeah, that snapped here, and this snapped here. I even have like some parts of this paddle are snapping. So I think it's pretty clear that this 72D TPU is just not the stuff to be using. The pads constantly snap. It doesn't print very well. It's not flexible enough, especially when it's cold. It's honestly about as solid as the PLA. I don't know. I don't know what the correct material would be. I would assume it would be polycarbonate, but like I said, I don't have the capability to print that. So yeah, this is kind of where we're at with the tank now. I'm gonna see if maybe I can beef this up in CAD some more, or try some different materials, maybe some PETG. Maybe try to rig up some sort of enclosure and try nylon on my printer, but polycarbonate is supposed to be really difficult to print with, and I just don't think a thrown together enclosure is going to work with that. Yeah, that's the current state, and I'll probably post again if I make any real progress.